divisibility rules questions with the reminder theorem. Those things we'll have a discussion. I collected some of the questions which are given in the previous papers. We'll have a discussion on those questions once. TCS question last class. Yeah, fine. Yeah, I do remember the question which I have projected in the last session. So let me discuss that and then we'll go with the divisibility rules because it's a connecting question. Yesterday I have shown one question which is given in the previous Capgemini paper and as well as previous TCS question. Let me take that question once. So question is given in such a way that 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial and so on till 100 factorial is divided by 6. If this is a number n, if this number is divided by 6, if this number is divided by 6, what is the remainder? This is a question which we have taken at the end. This is a model question. So how to deal with this type of model question is very simple. Only the point which you have to remember as we discussed in the reminder theorem in the last session. So what is the points which you have to remember is whenever you are dealing with the reminder theorem, remember the basic reminder theorem concept. What is basic reminder theorem concept is? Basic reminder theorem is telling that whenever we have a product or addition of numbers, like for example, we have a numbers like a into b into c is divided by k, they are expecting us to find out what is the remainder in this case. So how can we find out the remainder in this cases? You can go with the individual reminders. That means you can go with a by k reminder, you can go with b by k reminder, you can go with c by k reminder. After getting the individual reminders, you can multiply all. If you are getting a reminder which is less than your dividend, then keep it as it is. If you are getting more than, then divide it again. That means, for example, if we are having any question as like this, 36 into 38 into 40 is divided by 7. What is the remainder is the question. Then what we can do, you no need to do multiplication of all these numbers. You can directly go with the individual reminders. So when we divide 36 by 7, what would be the remainder? 7 5s are 35. 36 means you are going to get 1 more than the actual dividend 35. So we are going to have a remainder as going to be 1 here. So 38, if I divide with 7, what is the remainder? 7 5s are 35. So we are going to have a remainder which is going to be 3. 3 more than the actual dividend. 40 divided by 7. What is the remainder? 7 5s are 35. We left with an extra remainder of 5. So we have the individual reminders as 1, 3, 5 and the operation between them is multiplication. Because we have a multiplication operation here, you can multiply all of them. So 1 into 3 into 5 is giving a result as 15. 15 if you divide with 7. See, if you are getting 15, don't take that as a reminder because the basic point which I have told you in the last session is whenever you take any number, if you are dividing this with k, then you will always get the reminders which are lies between 0 to k minus 1. There is no chance of getting a reminder which is more than the dividend. You will always get a reminder which is less than the dividend. If you are dividing with 8, for example, you will get the reminders as 0 to 7 only. You know, you are not going to get 8 or you are not going to get more than 8. That's the only one point, you just keep it in mind. So 15 is divided by 7. What is the remainder? So 15 I cannot take directly because 7 is my dividend. I have to get a remainder which is less than 7. So 7 2s are 14. We left with a remainder of 1. That's how we can deal with. So here one point you just remember, it is not only for multiplication, my dear students, even the operation is addition, you can perform the same thing. That means, for example, if I have any question as 12 into 13 is divided by 10, what is the remainder is the one question I am projecting. The other question is 12 plus 13 is divided by 10, what is the remainder? The other question I am projecting. So if you look at these two, the first one is 12 into 13 divided by 10. So if I'm dealing with 12 into 13 divided by 10, 12 into 13 divided by 10, what is the remainder is, you can just look at individual reminders. 12 by 10 remainder is 2. 13 by 10 remainder is 3. 2 into 3 remainder is 6. You can mark it as 6. Here the operation is addition. Only the difference is operation is addition. Same numbers and everything. So again go with the individual reminders. 12 by 10, 2 is the reminder. 13 by 10, you are getting 3 as a reminder. What is the operation between them? We are able to see the operation between them is addition. So 2 plus 3 is giving a result which is equal to 5. You can mark it as answer choice. The similar kind of concept you can execute for all the numbers. So here you are able to see the previous TCS and previous Capgemini question which is projected in such a way that it's given in factorials. So dear students, please don't get confused by looking at the factorial. Okay. So here we are having a numbers. Here we are having a numbers as 1 factorial plus 2 factorial plus 3 factorial and so on till 100 factorial. When we divide this number with the 6, what is a remainder? So let me apply the basic remainder theorem here. So if you are dividing whole thing with the 6, so you can go with the individual reminders. 1 factorial divided by 6 plus 2 factorial divided by 6 plus 3 factorial divided by 6 plus 4 factorial divided by 6. Like that, it will go on till 100 factorial divided by 6. So now what we need to do, try to get the individual reminders now. So what is the value of 1 factorial? 1 factorial is nothing but 1. 1 when we divide with the 6, what is the remainder? That is going to be 1 itself. 2 factorial. What is the value of 2 factorial? It is going to be 2. 2 by 6. 2 by 6. What is the remainder of 2 by 6? It is going to be 2. So yesterday also I have given the same point, my dear students. Remember again, whenever we are dividing A by B, the remainder of A by B is always going to be A if and only if the B value is more than the A value. B value is more than the A value. That means, for example, if I have anything as 3 divided by 5, what is the remainder means? I can directly take remainder is 3. 1 divided by 7, what is the remainder? Remainder is going to be 1. 5 divided by 10, what is the remainder? Remainder is 5. So dear students, simplification is something which different from the finding remainder. Remainder is something which is left over after dividing. So don't do simplification when you are finding the remainder of any particular expression. Okay. So please keep it in mind, because I have seen some of the students, if it is 10 divided by 5, what is the remainder if it is a question? Students are saying it as 1. Students are saying it as 2. So 2 is called simplification, my dear students. I am not asking the simplification of 10 by 5. 10 when we divide with 5, what is the remainder? 5 ones are 5, 5 twos are 10. So we have nothing which is left over. It is completely divisible. So remainder should be 0. Okay, don't get confusion for these kind of points. These are very basic points, but students are commonly doing this kind of mistakes. So avoid doing this kind of mistakes. So, and if you have any larger number on the numerator, it is definitely not going to be any more big challenge for any student. 13 by 4, you can immediately say 4 3s are 12 and we left with the remainder as 1. These are all we have done in the school standard. So remember, when we have a more denominator, directly you can take the numerator as a reminder. So here you are able to see the question which is projected as 1 factorial by 6. That means 1 by 6. Directly you can take remainder as going to be 1. Then 2 factorial by 6, 2 by 6, remainder is going to be 2. So 3 factorial divided by 6. What is the remainder in this case, my dear? 3 factorial by 6. 3 factorial is nothing but, it is going to be 6. 6 by 6, what is the remainder, my dear students? 6 by 6, remainder is going to be 0. After this, you no need to solve. What is 4 factorial? 4 into 3 factorial by 6. We are getting remainder 0 here. 0 into any number is 0. All we are going to get remainders as 0. So what is the overall remainder? 1 plus 2 plus 0. So overall value is going to be 3. 3 divided by 6. We have to find out the remainder. Remainder is going to be 3. Mark your answer choice as going to be 3. I hope you are able to get the point. So I hope you are able to get the point. Similar kind of question I have seen in the previous TCS paper also. Let me project that question as well so that you will get a clarity. So the question is projected in the previous TCS paper, TCS Ninja. Please all of you try for this question. Question is projected as in this way. N is equal to 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial and so on 2019 factorial whole raised to the power of 2023 whole raised to the power of 2023. When you divide this number with 10, what is the remainder is the question. All of you please have a try. So actually the question is, when we divide by 3, what is the remainder is the question. Okay. When we divide by 10, what is the remainder is the question. I'll discuss two things here, my dear students. I'm asking a very simple question. Can you tell me what is the answer for this? 53 when we divide by 10, what is the remainder? 53 when we divide by 10, what is the remainder? What is the answer, my dear? Nice, very good, very good. So remainder is going to be 3 here. Remainder is going to be 3 here. 53 when we divide with the 10, remainder is going to be 3 here. tell me 64 by 10 remainder? It is going to be 4. 156 divided by 10. What is the remainder? Remainder is going to be 6. 159 is divided by 10. What's the remainder? Remainder is going to be 9. So I understood a point here. Any number, if you are dividing with the 10, if they are asking us to find out the remainder, what it means? It means that they are expecting you to find out the unit digit of it. 53 unit digit is what? 3. 64 unit digit is what? 4. 156 unit digit is what? 6. 159 unit digit is what? 9. So any number, if you are dividing with 10, if they are expecting us to find out what is the remainder, that means indirectly they are asking you to find out what is the unit digit of that particular number. Keep this point in mind. So why this point is going to be helpful in solving the question, or how it is going to be helpful in solving the question, you can just observe now. Now the given question is talking about what is the remainder when we divide this number with 10. What is the remainder when we divide this number with 10? So the remainder when we divide this number with 10 is nothing but they are indirectly asking us to find out what is the unit digit of the number n. What is the unit digit of the number n? That's the meaning of this question indirectly, right? So unit digit of finding the unit digit of this number is going to be very easy. We are already done with the unit digit concept. But only one difference which you are able to see from the previous question to this question, like previous unit digit questions we have solved. So previous to this, what is the difference is, previously we have seen the unit digit questions where the question is might be projected like this: 5642 whole is raised to the power of 461. What is the unit digit? In this case, how we are used to solve? So whenever you have any base, you can just observe what is the last digit available. That is going to be 2. 2 power 461. What is the unit digit of it? Whenever you are having a 2, if you observe the power cycle pattern of 2, 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is going to be 6. This is a power cycle pattern of 2. So now, because it is maintaining the frequency of 4, you can simply divide your power with 4 and observe the remainder. 2 power remainder itself is your answer as unit digit. So it is 4 power 61. What are the last two digits? 61. 61 when you divide with 4, what is the remainder, my dear? It is 1. So 2 power 1 answer is going to be 2. That's how you can deal with the unit digit. But here only the difference when it compares to the previous questions what we have already done to the question what is projected here is we are not having any direct base here. So they given as 1 factorial plus 2 factorial and so on till 2019 factorial. No need to get any confusion here. There is one simple thing. Let me start this. What is the value of 1 factorial, my dear students? 1 factorial is 1. Can you tell me what is the value of 2 factorial? 2 factorial is going to be 2. What is the value of 3 factorial? 3 factorial is going to be 6. What is the value of 4 factorial? 4 factorial is going to be 3 factorial is 3 into 2 into 1. 4 factorial is nothing but just 3 factorial into 4. That means 6 into 4. That is 24. What is the value of 5 factorial? 5 factorial is nothing but 24 into 5. That is 120. So like that you are going to get all the values. You can just observe. After 5 factorial onwards, what is 6 factorial? 120 into 6. Because the last digit is 0, you will get the last digit of 6 factorial as 0. 7 factorial will also ends with 0. Like that, you take any other number till 2019 factorial, all will end up with the last digit as 0 only. I am trying to find out what is the last digit of this whole base. So last digit of this whole base means 2 plus 3, 1 plus 2 plus 6 plus 4 plus 0 plus 0 plus 0 and all will be 0. So last digit will depends upon 1 plus 2 plus 6 plus 4. What is the sum of these numbers? It is going to be 13. So anyways, I am not focusing on the other digits, but I can definitely say that this whole base will be ending with a last digit which is equal to 3. So now the question is 3 power 2033. What is 2023? What is the last digit? What is the power cycle pattern of 3? 3 into 3 is 9, 9 into 3 is 7, 7 into 3 is 1. This is a power cycle pattern of 3. So it is 2023. So you can just observe what are the last two digits of this. This is 23. If I divide with 4, what is the remainder? Remainder is going to be 3. That means answer is 3 power 3. What is 3 power 3? Will ends with 7. That itself is a reminder when we divide this number with the 10. Answer choice is 7. Answer choice is 7. Answer choice is 7. Question. So answer choice for the question. No. Answer choice for the question is going to be 7. Answer choice for the question is going to be 7. That's how you can able to see the question. I will ask the question. I will ask the question. Please try to tell me the answer choice for the question. We'll continue this. So what is a very simple question for you? What is a divisibility rule of What is a divisibility rule of 3? What is a divisibility rule of 3? Can you please tell me, anybody? So all of you very well know that the divisibility rule of 3 is nothing but digital sum or sum of the digits must be divisible by 3. So you might be having this in your school standard. Sum of the digits must be divisible by 3. Sum of the digits must be divisible by 3. For example, we have a number 321. Is this number is divisible by 3 or not? If it is a question. So you can manually divide with the 3, 3 tens are 30, we left with the 3 sevens are 21, remainder is 0. We can say it is divisible. What is the other way of doing the same? We can also find out 3 plus 2 plus 1. What is the sum of the digits? It is going to be 7. So, sorry, it is going to be 6. So, if the sum of the digits is divisible by 6, we can say that is divisible. So, you no need to manually calculate like this. You can directly find out digital sum. If the digital sum is divisible by 3, we can say the entire number is divisible by 3. That's how we can tackle the question which is based on the divisibility. So now the question for you is why we are taking sum of the digits. We all know that the divisibility of 3 is nothing but the sum of the digits must be divisible by 3. We studied this from the school standard onwards. Why we are checking sum of the digits? What is the proof behind this? What is the proof behind this? So why we are taking the sum of the digits for the divisibility of 3? Divisibility rule of 3. Divisibility rule of 3. So try to check out and try to find out the reason why we are checking the sum of the digits for 3. So based on your reason, we will continue the tomorrow session. So tomorrow completely I will be working out on divisibility rules. We'll discuss all the proofs. You might be seen in all the whatever the material you take, you will be able to see some definition. A number is divisible by 2 if and only if the last digit is ending with 0, 2, 4, 6, 8. A number is divisible by 3, sum of the digits is divisible by 3. A number is divisible by 4 if and only if last 2 digits are divisible by 4. A number is divisible by 5 if and only if the last digit is ending with 0 or 5. A number is divisible by 6 if and only if divisible by 2 and 3. A number is divisible by 7 if and only if difference of alternative triplets must be 0. A number is divisible by 8 if and only if last three digits are divisible by 8. A number is divisible by 9 if and only if digital sum is divisible by 9. A number is divisible by 10 if and only if the last digit is ending with 0. A number is divisible by 11 if and only if alternative digits is difference of alternative digits must be 0. So a number is divisible by 12 if it is going with 3 and 4. All these are the rules which we already have in most of the books. So instead of reading that, we'll try to understand what is the reason behind it and what is the proof behind it. All those things we'll have a discussion. Please try to solve this. Why the divisibility of 3 is sum of the digits. Why the divisibility of 3 is sum of the digits. Try to solve this so that we can continue the session in the next class by discussing all the divisibility rules and the questions which are based on the divisibility rules. So I hope the point is clear. So we'll try to solve all the different types of questions which are based on divisibility rules and which are given in the previous papers. So in the next session. Thank you so much, my dear students. See you in the next session.